Number 1, I would set it equal to 0, so I would say y is 0. To find my x-intercepts, I would factor or use the quadratic formula, and that's how I got negative 11, 0, and 3, 0. I would put 0 in for x then to find my y-intercept, and I solve, and I get negative 33, so 0, negative 33. Yes, you must write them as ordered pairs, or I'll count it wrong. 2, you put in 0 for y, you cross multiply, so you get 0 equals x squared minus 4. You solve for x, and you get 2. Oh, wait, when you take the square root of 4, you also get negative 2. Yeah, some of us missed that on our quiz. Then for the other one, you put in 0 for x, and you get y equals 4/3. For 3, to find symmetry with respect to the x, y, or origin, to find with the x-axis, you put in negative y. So that's what I did there, and I simplified, and I got x-axis. To find y-axis, you put in negative x, and I simplified, and I did not get it to be the same, so y-axis was sad face. So that therefore means origin is not either. It either has to be all three, 1, or none. For 4, I put in negative y, and it did not simplify. I put in negative x, and it did not simplify. I put in negative x and y, and I get negative y equals negative x cubed over x to the 4th minus 1. So on both sides, it's opposite, so I multiply by negative 1, and I do get the origin to work. So watch those fraction ones. For 5, my point of intersection, I get both of them to y equals. I set them equal to each other. Since we have a x squared, I have to get it equal to 0, so I can either do quadratic formula or factor. I then factor, and I get x equals negative 2/3 and x equals 1. To find my y values, I plug in x to my one of my equations, either the y equals 4 minus x or y equals 6 minus 3x squared, and I solve, and I got 4 2/3 and 3, so I put them as ordered pairs with their corresponding x value. For 6, I did elimination, so I multiplied my second equation by 2, and then I added my two equations together to eliminate my x's, and then I solve for y. To solve for x, I plug in negative 8 for y and solve. Whoa. 7, to find the slope, you do the change in y over the change in x, and I got 15 over 4. 8, you do the change in y over the change in x, and I got 11 over 4. Remember, your ordered pairs go x, then y. On 9, I have my slope, so I put that in for my m value, right there. Then I put in my ordered pair for x and for y, and I solve for b, and I get b equals 2.5. So I write my equation, y equals negative half x plus 2.5. For 10, I didn't have my slope, so I have to go and find it first. So I went and found it with the change in y over the change in x and got 3/5. You can use any of the ordered pairs that you want. You can use negative 10, negative 9, or negative 5, negative 6. You plug in for x and y, and you solve for b. And I got negative 3, and I put it all together. For 11, you have to find what the slope of the original line is. So that's why I put it into y equals form there. Since this slope, is 5/3, my parallel slope is 5/3, and my perpendicular is negative 3/5. So to find your b value, you put in the 5/3 for the slope for the parallel line, and you put in your ordered pair for x and y, and solve for b. For perpendicular, you do negative 3/5, put in your x and y, and solve for b. 12 is the same way, and we get y equals 3/2 x plus 2, and negative 2/3 x plus 6 1/3. For 15, you plug your x value into whichever equation it fits into. So if it's less than 0, x is, then you plug into the top. If it's greater than or equal to 0, you plug into the bottom. So I got 18, 2, and 1. All right. Here, it doesn't look like I showed my work. For symmetry to even, it has to be y-axis symmetry. For it to be odd, it has to be origin. And for neither, it would be none of the above. So there's my answers there. And you can do symmetry because we did problems like that before. All right, now we're ready for Chapter 1. Chapter 1, number 1, I factor because if I plug in 2 immediately, I can't, I get undefined. So I factor and cross out, and that's where I get 1 over x plus 2. So I plug in 2, and I get 1/3. For 2, I can immediately plug in negative 3, and I get a limit of 0. Yes, your limit can be 0. Your limit just can't be undefined. For 3, I plug in 1 immediately and I get 5. For 4, I plug in 1 immediately and I get negative 2/5. For 5, I have to multiply by the conjugate, and that's what this fraction right here is. And when I multiply it, I get this right here. And I simplify my top and I get that. And then I pull out a negative 1 on the top. That way I can cross out my x plus 3. And I get this right here. So then now I can actually plug in negative 3 and not get an undefined value. And I get negative 1/4. For 6, I can plug in already and get 8. For 7, it's the same as number 4, so you don't need to do it. For 8, it factors. And I can cross out and then plug in negative 4 and I get 48. For number 9, I can factor the top and the bottom, cross out, plug in 3, and I get negative 1/4. For 10, I can take a negative 1 out of the top, I can factor the bottom, I can cross out, and I get negative 1/4. 11, you can't plug in, and you can't factor, so I'm going to look only at the right side of 2, since it has a little plus sign, and I get negative infinity. For 12, I can factor, so the little negative sign on the 3 doesn't matter, and I get 4/5. 13, I can't factor, so I have to plug in values on the left side of 0. I don't have to worry about the right side, and I get negative infinity. For 14, I can factor, and I get negative 1/4. 15, factor, and you get 1/3. 16, can't factor, do a chart, and you get infinity. Only have to look at the right side. 17, chart, and you get negative infinity, and you only have to look at the left side. Alright, chapter 2. We are going to do the derivative. For number 1, I did the product rule along with the chain rule. If you notice over here, here's the chain rule. I did not show my work, but u would be the 3x minus 1, and du would be your 3. And it simplifies to this right here. Number 2, I would do the chain rule. I didn't show my work again, sorry. I would have u to the 7th, and that's where I get 7u to the 6th. My derivative of u is this 18x squared minus 5. For 3, you just do each part, 3y squared y prime. This part right here, you had to do product rule for the negative 4xy, so that's how I got this part in the middle. Derivative of x squared is 2x, derivative of 20 is 0. You move everything over to the other side that doesn't have a y prime, so that's why this stuff is over here. I then factor out a y prime and divide by my parenthesis, and so my answer is up here. For number 4, I have to do chain rule, so I rewrite them as u to the 7th, and you could do u to the 8th. So I get 7u to the 6th, derivative of u is cosine. For the u to the 8th, I get 8u to the 7th, derivative of cosine is negative sine. So there's that answer. For 5, you have to do chain rule as well. So you do sine of u, which is cosine u, then times the derivative of u, which is 1/6. For 6, you have to do quotient rule. And if you want to go ahead and multiply it all the way out, you can do that, and there's all your answer. For 7, you have to do chain rule for this cosine. And so this is what you get when you do the derivative. You then have to distribute your 3 and your y prime, and get that. Then I move my y prime 1 over to the other side, so I added it. They both have y prime in common, so I factored it out. I then divide by what's in my parentheses, and I get my final answer. And hopefully that will be a good explanation for your review. If you have more questions, feel free to email me or ask me on Twitter or Facebook.